So hello guys, in the previous live session we have seen about many of the number problems and for loops and nested while loops. Within that, using those nested for loops we have solved more number problems. Now in this live session we are going to master arrays. So first let us see the basic structure of the array. The structure of the array will be look like this. So this is the basic structure of the array. In C, the one of the fundamental and the critical data structures, most of them will encounter is array. So in this video we are going to cover the topic of array, and moreover we will be solving more problems based on that. So make sure to follow along with it. An array is the collection of elements of the same data type and it is stored in a continuous memory. So each element is accessed using the index values. It will be starting from 0 to n minus 1. For example, let us take a sample array. In this array, if I store any value like this, so the size of the array is 5. So this is called as n. So here the index will be starts from 0 and 1, 2, 3, 4. This last element is nothing but n minus 1. So this n is 5. So 5 minus 1 is 4. So we got the last index and this is the 0 is the first index. So this is the basic structure of array, and within this array the elements will be stored and the data type of the every element is same. If you use different type of data types, the C compiler will throw an error. For example, 3, 4, 5, and if you give any 6.4 like this will throw an error. It can't store float value inside a integer array. So now let us see the basic declaration and the syntax of the array. So the basic syntax of the array is data type, after that array name, under square brackets, within that we have to give the size. So this is the syntax for declaration of array. So the data type, the array name, and the square brackets within the size. So let me give some examples. Let us see some more examples. First, let me create an integer array. So the first data type, so integer. After that, the array name I am giving ARR, or if you have to name it, so it is an integer. So I want to store marks. So I am storing so here I am storing marks. After that, the size. I want to store 5 elements, so I am giving the size of 5. So this is the syntax for creating an integer data type array. So now see for the float. So here I want to name it as, for example, prices will be in the decimal value. So I am giving prices and I am giving the size of 10. So after that, one more array is there, that is character array, character and name. For example, let me give 20 here. So this is nothing but a character array, or else we can say a string. So this is the declaration of the array. So let us see the initialization of the array. That means we are initializing some more values into the array. So initialization. So here first we have to declare as well as initialize. So the data type. So I am giving marks. So the size is 5. After that I am giving values within it. So here the 0th index will have 10 and first index will have 20, second index will have 30, fourth index will have 40 and fifth index will have 50. So like this we have stored. So in this there is not 4, it is 3 and 4. So in here this is how we will be storing this. So next we will be seeing for some more arrays. If you declare int, for example, if I give an array of zeros and if I declare 0 here, so now all the elements in the array, for example, let me give 5 here. So the array size is 5. In this, if I give this value, all the elements in the array will become 0. If I don't initialize this and just declare like this, the array will have some random garbage values. If you try to print, it will give some random values. It may be negative or positive. Some more random values will be printed. So that is called as the garbage values. So we will see the memory layout of it. So when you declare an array, for example, if I declare any array, integer, and I am naming it array of 5. So now what will happen? C will be reserving a continuous memory space of 5 reserved elements. So in the most of the systems, each of them will be 4 bytes. So this is the basic capacity of it. First, array of 0 will be at the base address and it will have 4 bytes. After that, array of 1 will be there and array of 0, 2, 3, 4, like that it goes on. So let me take an example. So array of 5. So 10, 20, 30, 40 and 50. So this, it will have, if I want to access this element, I have to use the index value. So if I print this array of 0, that time I will get 10. If I print array of 1, I will get the second element, that is the first index, 20. So after that, if I print array of 2, so that time I will get 30. So basically the address of it will be starts from 1000. So the array of 0 will be at the address of 1000 and it will be at address of 1012 and after that address of 1016, like that it will goes on. So it will be storing in a different address. And if you have familiar with the pointers, so the array name is the pointer to the first element. This array name is the pointer to the first element. And if I try to print, for example, so if I try to print the pointer value, that is pointer data type, that is p, after that the array name, it will print the address of array of 0. So if I try to print the pointer address, and give array of 0, I will get the same address. So let us check it in the compiler. So first I am using header tag, standard input output dot hex. After that main function and return 0. So in here I would like to declare any array. So for example, I will declare the same array, that is int array of 5 is 10, 20, 30, 40 and 50. So this is an array. So in this, if I want to access the element %d, that is the data type of it, and array of 0. So if we print array of 0, this 10 will be printed. So now let us try to print the pointer of this value. So first we will print the array of first element and the name of the array, that is, so as I said there, both will return the same value. So let us check it. So it both returns, let me give some next line. So as for the compiler value, it should return the pointer of the next value. So let us move on to the basic operations in an array. So first we'll get the input from the user, after that we'll print from it. So for that, first we'll declare an array. So I am declaring an integer data type array. So int the array name, after that the size. So I want to get the size from the user, so I am declaring it as n, and I am getting in the size from the user. After that I store it here. So the size will be stored here. So this will be the size of the array. So after that I am using a for loop. So the index value will start from 0 and it will less than the n value, and it will be increased by 1. So using this for loop, I am getting from the address of it, first it will be 0 and the array of 0 will be stored and array of 1 will be stored, like that it will store. So after that, let us try to print it using another for loop. So we'll use index value to print it. So the index value will be starting from 0. So it will be less than n and I plus plus. So I am printing array of 5. So let us try to print it. So I am giving the size as 5 and the elements as 1, 2, 3, 4 and 5. So see here, it is printing the elements 1, 2, 3, 4 and 5. So I am given next line here. If I remove and run it, and I am again giving the value. Now I am giving size of 7. So see here, we got the input and we got the output. So this is the input I have given and it is stored in the array. So now I am printing the elements that is stored in the array. So this is one of the basic methods that we will get input from the user. After that we are printing it from the user. So here what is happening, the array of 0 is 1 and array of 1 is 2, array of 2 is 3, array of 3 is 4, array of 4 is 5, array of 5 is 6 and array of 6 is 7. So let us move on to some more problems that is related to it. So first I would like to go on from adding all the elements in the array. So if I give like this, for example, if I give 1, 2, 3, 4, I want to get the output as summation, that would be 10. So 1, 2, 3, 4, that would be 10. So let us see that. So I am using a for loop again. So for storing it, let me open this notepad. So there will be some values like 1, 2, 3, 4. So I have to add it. So I will get the value of 10. To store this 10, I need any variable. So I will declare one variable, that is integer sum. So I will initialize with 0. So now I will use a for loop to iterate through this array. So int I will be 0 and I less than n and I plus plus. So I want to add, first sum will be 0. So 0 equal 0 plus, that is sum plus, after that the current element, that is array of I, because I will be having a 0th index to n minus 1 index. So to store it, after adding these many elements, we just need to print it. So here I will be printing sum. So is the sum of elements in the array. So let us print it. So now let's give some value of array of size of 5. After that 1, 2, 3, 4 and 5. So if I add it, I would get the output of 15. So let us check it. So 15 is the sum of elements in the array. So we are adding through a for loop. We are iterating through every index and getting the value. After fetching it, we are doing the summation. After that we are printing it. So we will calculate the average of the array. Average will be calculated by, if there is an array, first we have to add all the elements. After adding all the elements, we have to divide the total sum by the number of elements in the array. So there are 4 elements. So if it is the value, so we have to divide it by 4. So it will give 2 for the integer division. And if you move on to the float value, so it will be like 2.5. So now let us try to code it. So now I'll create float, that is average. So the average is, I am declared average. So now we have to calculate the average. So the average is the total sum divided by n. So after calculating it, I would like to print the average. First we will use next line here. After that %d is the average of the elements in the array. After that the value. So now let us print it. So for that I will give the size of 5 and the elements 1, 2, 3, 4, 5. So it currently says 0 because 15, the total sum is 15 and the current value of n is 5. So it is dividing 15 by 5 and returns value of 0. So let us check here and give space. So let us give 3 and 1, 2, 3. So it still returns 0 here because there may be errors within this. So let us check here. So it is, we have given float here. So we have to give integer. So again we will give values. So now it shows 3 is the average of this element. So that is the middle element. If you add it, you will get 15. So 15 by 5 will return the value of 3. So if you want to get the value in the float value, so that time we have to use type conversion. So for that I am making it as float. So after that we have to convert it float. Then while printing it, we have to do one more thing. Before that, I'll convert this also. So now for float we have to use f, but I want 2 digits after it, so I am using 0.2x. So now let us run it and I am giving the size is 4 and the elements 1, 2, 3, 4. So it says 2.50 is the average value of the elements present in the current array. So for converting we have to use type conversion. I am converting both values into float. After that I am calculating it and I am printing it. So if you give if I give float and use percentage %d here, I will get the value of 0 because both data types are different. So if I give 5 and 1, 2, 3, 4 and 5, so we will get the output as 0. So for that the data types have to be same. So percentage, so I am using float here. So let us run it and check one more time. So the size is 5, 6, 7. So the average is 5 for this current array, that is 6, 7, 5, 4, 3. So let us move on to the next problem. We have to find the maximum element in the array. So let us remove this code. So first hash include standard input output dot fetch. So after that we have to create one main function and return 0. So in this program we are going to find the maximum element that is present in the array. So for that, first I'll declare one integer array. Before that we have to get the size from the user. So first I am printing enter the size of the array. After that I'll declare the n and I am scanning it. So after getting the size of the array, we have to get the elements in the array. So for that, print, I can say enter and percentage %d and n, because the n elements of the array. So after that I am using a for loop. So I value is 0, I less than n and I plus plus. So now I am using another scanf to store the elements. So within this it is integer data type. and it will be stored in array of I. So before that we have to declare the array. So here I'll declare it array is with the size of n. After that we are getting the input and storing it in this current array. So now we got the array. So first let us print it. So printf the elements in the array. After that I am using one for loop and I am printing it. So we are printing the elements in the array. So now first run this code and check it. After that we will move on to the maximum and minimum. So the elements in the size of the array is 5. So the 5 elements are 1, 2, 3, 4 and 5. So the elements in the array are 1, 2, 3, 4 and 5. So it is working. So now let us move on to the question. So let me take this as an array. So this will be the array structure, and 1 will be there, and 2 will be there, 3, 4 and 5. So this is the basic array structure. First we will iterate through this array from starting to the ending. First I initialize one value or a variable, the maximum element. First I initialize with the first element, that is array of 0, because we are going to anyway start from it. So first I initialize with the first element, that is 1. So I'll check 1 if 1 is less than the second element. If it is less than the second element, so it will be greater than this value. So next time I'll change the max value to this. So let me remove this initialization part, or else we can go with 1. After that it will move on to 2. So now 2 will be checked if 2 is less than 3. So it is true. So 3 will be as the current maximum element. So I'll check the current maximum element 3 less than 4. So it is again true. So 4 will be the current maximum element. So 4 less than 5. So it is true. 5 will be the maximum element. The loop will be stopped and we will print the maximum element 5. So now let us write this concept in here. So for that we are going to store it in an array, that is int. So I am m for max. So I am initializing with the first element in the array, that is array of 0. So after that I am writing a for loop and I am starting from the first element, 0th index and less than n and I plus plus. So in here, if what we are checking the maximum element with the current index. If my maximum element m is less than the current element, that is array of I, so that time my maximum element is my current element. So after that it will check and change the values inside this for loop. So next we have to print the maximum element. The maximum element in the array is m. So let us give the value. The array size is 5. The 5 elements is 5, 3, 4, 2, 6, 7. So we will be giving next line here. After this elements in this array, so we will have to print one more thing, that is print of next line. So after this printing the elements in the array, it will move on to the next line. So 5, and I'll give 5 elements as 5, 4, 7, 3 and 2. So this is the elements in the arrays, and it is returning 7 as the maximum element. So let us see here. I have given the elements of 5 and 4, 7, 3, after that 2. So I will initialize with the 0th element. Currently it is 5. So 5 less than 4, it is false. So 5 will be the greater element. After that 5, this 5 less than 7. So initially first it will check 5 0th with 0th element, that is 5 less than 5, false. So it will move on to the next element. 5 less than 4, false. After that 5 less than 7, it is true. So the maximum element will change to 7. 7 less than 3 is false and 7 less than 2 is false. So maximum element is 7. So 7 will be printed here. So same like that we are going to find for the minimum element. So in the same logic we will check if array of first we will initialize with the first element, that is 5. So now I will check if 5 is greater than 4. Okay, that time I will change this value. First 5 greater than 5 is false and 5 greater than 4 is true. So after that 4 is greater than 7. So that is false. So in this range, see here, we are getting that we will be checking that if the current element is less than this number. So I am naming it as minimum. So here, if my minimum element is less than this number. So if first initially it is 5. So minimum element less than 5. That is 5 less than 5 is false. It will move on to here. And 5 less than 4 is true. 5 greater than 4 is true. So that time that is the minimum element is less than. That means if it is greater, so we are checking for the minimum element than this current value. So if this current value is greater than this value, we will swap it. So that time we will get 4 here. So we will check, that is 4 is less than 7 like that. So in here it is not. So it is move on to the next value. So the current value is less than this minimum value. So it is minimum value. So it will check and change the value of 3. So the minimum value is less than this value. Then after that it will check and swap it. So we are checking for minimum value like that the same value. So we will check one more thing, that is, so I am declaring, I am naming it as M. Okay. So after that in we will name min equals array of this. We are initializing with the first element. After that, if my minimum value is greater than the current element, so that time I will swap it. Okay, see here we are checking less than, here we are checking greater than here. So first I am checking that 5 less than 5, false, 5 less than 4, like that. That's when it come to here, that is, it will become true. In the case of that 5 is greater than 4, so that time it is true. So we are changing it to 4. So now we are again checking that 4 is that 7 is less than 4. So no, after that 3 is less than 4, so it is true, will change, and 2 is less than 3, it is true, that we change. So let us print here, printf. So within that next line, after that the minimum element in the array is the minimum value 5, and let me give 3, 5, 1, 7, 2. So the maximum element in the current array is 7 and the minimum element in the current array is 1. So we are checking both in the single loops, and we are checking that if the current element is greater than or not or less than or not with a simple if condition. Using this if condition, we are storing this value in two variables and printing it. So let us move on to the next question. That is, we are going to reverse a array. So for the reversing, there are two methods there. That is, we will be reversing it, and one more thing, that is, we will not reverse it. Instead of that, we will be directly printing it in the reverse order. So we are printing it from forward here. So let us see here. So 5 and 1, 2, 3, 4, 5. So the elements in the array is 1, 2, 3, 4, 5. So now I am using another printf. So here before that I will use next line, and the reverse array elements is so in this for loop, here we are started from the 0th index, but we will start from the last index. The last index is n minus 1, and we will be coming up to 0th element, that is greater than or equal 0, and we are decreasing one by one. So I minus minus. So after that we have to print the array element. So now let us check. So size is 5 and the elements are 1, 2, 3, 4, 5. So the elements in the array is 1, 2, 3, 4, 5. The reversed array elements is 5, 4, 3, 2, 1. So we are reversing in the reversed manner. That is, we are printing in the reverse manner from last index to first index. Instead of printing, we are going to entirely swap the elements after check it. So for that, let us see here. So first I'll remove this. So in this array, I'll give some values 5, 4, 3 and 2, 1. So for reversing, after reversing it will be look like this. That is 1, 2, 3, 4 and 5. See here, this element and this element. If you see here, these two elements are interchanged. That means the first element and the last element is being swapped. So let me break through it. So here first we have to swap the first and last element. If we swap it with 5 and 1, so we will get 1, 4 will be there, and 3 will be there, 2 will be there, and 5 will be there. So we are swapping this 5 with the 1. So now this both of them are swapped. So after that I'll move here and I'll swap 4 and 2. So if I swap 4 and 2, so 1 will be there. We have to swap 2 and 4. So 2, 3, 4, after that 5. So as you can see here, now we have entirely swapped this array. So what we have to do, we have to swap from starting with the ending value, and we will move on by one from left to right. So we are going to do that. For that we are going to use a while loop, because see here it is the middle element. So if it comes to here, that is the current middle element, we need to stop the loop, because this pointer will reach here and this pointer will reach here. So if left value is less than right value, that time I can move it. If it is greater than the values, that means it will pass through here and it will pass through here. So now it will become 1 and it will become 4, or else it will become 3 here. So that time we need to stop the loop. So that is the condition. So we are going to reverse the array. So while I am giving two conditions, that I am using two pointers, that is left and right. So for that int, the left pointer will be starts from 0th element and the right pointer will be starts from the last element, that is n minus 1. So if left is less than right, so I can swap the element. So we know the swapping. So for that we have to use a temporary variable to store any one of them. For example, if I take left, after that I have to use array of left with that remaining value. That is array of right. Now we got the left value. So now we need to store the right value. Array of right will store the temporary value that is stored as the array of left value. Now we are swapped. After swapping the two values, after swapping these two values, we have to move this pointer by 1 and reduce this pointer by 1. So left is increased by 1, that is left plus plus, and right is decreased by 1, that is right minus minus. So now let us see. So we are printing the normal array. After that we are reversing it and we are printing the reversed array. So if we print it, we have to get the same value. So we are getting same value, that means the array is being reversed. So let us check here. After reversing it, how it's being written. So let us run it. I am giving 5 and the value is, let me give it in the reverse. So that time we'll get, this is the given array 5 4 3 2 1. This is after reversal. We are printing it in the reverse order, that means we'll get the original array values. So let us try to print the array of first element. So percentage d and array of 0 is the first element. So let me give some values 5. So I am giving 5 4 3 2 1. If it is reversed, the 0th index value will be 1. So the 0th element value is 1. So I will give next line here. So 5 and the elements is 1 to 5. So see here, I am given 1 to 5. So the last element will be reversed to the first element. So the current first element is 5. So we have reversed the array using two pointers, and it is starting from first to, one is starting from first and another one is starting from last. So using this we are swapping it. After swapping we have changed it. So let us do one more problem, that is counting even number and odd number. So up till here we'll just comment it, or else we can simply remove it. So here we have get the element and we are printing the same element. So now we have to count the odd numbers and two even numbers. So for that I'll declare two variables. One is odd and another one is even. So both variable I will initialize at 0. I will count if any odd number or even number. So we will go on to the for loop for int I value is 0 and I less than n. After that I plus plus. So if my current array element is divided by 2 and return the remainder as 0, that is a even number. So I will increase even by 1. If it is not even, it will be odd number. So else odd number plus plus. So after that we will be printing it, how many numbers are there. So print the number of odd numbers in the array is percentage d odd. So after that, the next line, the number of even numbers in the array is the stored value. So let us print it. So I am giving the size 5. After that, so there is one even number and 4 odd numbers. So the number of odd numbers is 4, the number of even numbers is 1. So we will be using next line here and run it. I'll give some values as 8 and 2, 4, 5, 3, 1, 6, 7 and 8. There are 4 odd numbers and 4 even numbers. So this is the code for finding and counting the even and odd numbers. So let us move on to the next problem. So the next problem is we are going to copy one array and store it in one more another array. So let me remove this code. So here first I got the array from the user. After getting it, we have to copy it to another array. So I am naming this array to, for example, let me name it as source. And I'll create one more array, that is destination. So in this array, I'll use the same size and I'll store the values. For I is 0, so I less than n, I plus plus. So what we are doing, we are getting the value in the array of source file to store it in a destination file. So destination of I am storing, this is the location and this is the value. So the value is source of I and I am storing in this destination. So let us print the destination array. Let me copy it and paste it. Here I am changing destination. So here let me give next line and here as well. Of source. So let us run here. So pi and there are 5 elements. So this is the source and this is the destination. See here we have different array names, that is source and destination, and we are storing that array to this array using the index values from I to the n. First we have to create the size of the same size array. After that we have to copy each elements. So let us move on to the next question, that is inserting a element in the given position. So inserting a new element at the specific index in an array. So for that we have to shift the existing elements to the right to make a row. So for that first we will code it. So here let me remove this. I don't need this. So this is enough. So after that we have to do one more thing. For this program is to get the size, and after this line is getting elements and printing the current array. So now we are going to write code for inserting an element in the specific index. So for example, I'll take one value, that is int. We know the size, that is n. So int. So I name it as index. So I want to do it in second index. So before that I like to get the index from the user. So int index. So scanf. So before that I'll use printing statement. Enter the index to be insert. To insert. After that element. So let me take it as target. Enter the element to be inserted. So after that we have to use a scanf. So we are getting the target element and the index value. So now first what we have to do, will starts from the n, that is for int. So here the I value is n. Okay, the first thing is the array should be the value of I plus 1. So that time we can get the value and push it regarding that. So if there is no elements, because the array is fixed size, so we need the size of array plus 1. So for that first we have to create one more array, or else we have to give the array size plus 1. So we have to get the user array of size plus 1. So let them give that. So here we have to give n plus 1. So that time we can store the extra element here, because that is the fixed size. So for I value is starts from the last element. So that time we will be inserting it in the correct index. So I value is n. So after that I is greater than the current index and I minus minus. So here what we are doing the current index value before element. So we are moving, shifting elements by one step. So that time we will be shifting the current element to the next element. So we have to specifically push the element towards it. So after this for loop, the array of, that is the source of indexes, the current index will be switched with the target value. So after that we can increase, so we have increased the size. So now for int I is 0, so I less than n, I plus plus. So here we will be printing the elements in the array. So let us check. So this is not needed. So let us check here. Array size is 5. So elements is 1, 2, 3, 4, 5, 2 and 77. So it is being indexed, so we have to give +1 here, because we are adding one more element, so that time it will not be printed. So this printing statement I'll just remove it. So let us check here. The size is 5 and I'm giving value 10, 20, 30, 40 and 50. So the index I want to put it is the second index, that is the value currently in 30. I want to insert 25 in there. So 10, 20, 25, 30, 40 and 50. As you can see here what we are doing, we are incrementing the size of the array by 1. After that we are right shifting the element by 1. We are starting from this index and after that we are moving these elements one by one to the next element. So that time it will be move on to the next element. So after doing that we are inserting the current element to this. So this element will be moved to the next element and this element will be moved to the next element. So likewise it will move on to that. So after that we will be inserting the current value with nothing that is stored in the current value. Okay, so the values will be there 50. So after that 50 will be stored to this value and 30 will be stored to the next value and 25 will be stored to the next value. Like that, first we are shifting these three values and doing it. So as you can see, the structure will look like this. So in this, let me take 5 elements. So 10, 20, 30, 40 and 50. But the size is one more thing, because we have to insert an element, so the size have to be incremented by 1. So now what I am doing, I will iterate through the last element and I am copying it and pasting it here, and I am copying it and I am storing it in the next element. Copying, I am copying this 30 and storing it this value. So now the desired indexes will have the same value, but it is freed and we have moved all of the elements to the right side. So now we will be changing this value, that is we want to be the target. So that time this value will be changed. So that time we are initializing from the last -1, because the size is n plus 1. So if we start, it will get before the value, so that is n. So after that I greater than the index, that is the current index, we are getting to that and we are swapping the before value to the current value. So this is how we will be inserting the element to the given specific position. So let us move on to the basic problems that we'll be facing on in most of the interviews, that is searching. So there are two types of searching is there. For example, this is an array. So let me give one more value, that is 78. So in this array, I can search in two ways. That is, one is linear search. Another one is binary search. So in this linear search means you will start from the first index to search through the last index. So when you finally reach this last index and you didn't get, you will not get any value. But for the binary search, first you will get to search in the middle element. And in that, if you see, that means, for example, the target, let me take one target element. For example, my target is 30. So here, for the linear search, first I'll check 10, after that I'll check 20 and 25 and 30. But for binary search, I'll directly search the middle value, that is 30. So if it is not 30, for example, let me take it as 50. So first I'll check the middle element. So if my current element is less than the target, I will skip the leftmost half and I will move on to the right half. Within this right half, again I will check the middle element, that will be again 50. So 50 will be found. But for the linear search, I will check 10, 20, 25, 30, after 40, after that only I will search the 50. So the binary search, first we will check the middle element. So if it is not the value, we will check if it is less than or greater than. If the target is, for example, let me take it as 10. So let us check 30 here. So the 10 is less than this value. So I don't need to check this right side. I only need to just check these three values. So in this, the middle element is again 20. So 10 is less than 20. So I'll skip the right half. After that, I'll move here. Again, the middle element is 10. So the 10 is the target we have found with the 3 loop. So this is how we will be using linear search and binary search. So first, let us see linear search. So let me remove this. So we are getting the input from the user. After that, we want to get the target element. Int, I am getting target. After that, I'll print enter the target element that we have to search. After we are getting the element, we have to iterate through this array. So for that, I'll use one variable to store the index of the element. So initialize with -1. If it is -1, that means the element is not found. If it is any other value like 0, it is in the 0th index. If it is 5, it's in the 5th index. Like that we can change it. If it is -1, it is not found in the array. So next we will search through the every element. So we know that we will start from the 0th index and end through the last element and I++. If my current element is the target, so that time my index is my current value of index, that is right. The index is the I. After that, I don't need to check anymore. So I'll break here itself. So I'm checking it, and if I found, I'll break here. After that, I'll come out of this. If, see here, if I don't find, the index will be still -1. So if my index is not equal to -1, that means I have found the element. That time I'll print the element value is found in the array at the index of this index. If not, I have to print the element is not in the array. So here I don't need this much. I'll just remove this. After that I'll remove this. The element is not in the array. We have to use comma here. So we are checking from every element. If I found, I will be break there itself. And if my index is not -1, that time I will be found any index. That means we will be found the value in the any of the index within the present array. So I'll give array size of 9 and I give value of 1, 2, 3, 4, 5, 6, 7, 8 and 9. So if I give the value of 9, it says the element 9 is array is found at index of 8. So we need to check how many times this loop is running. So that time we can say which loop is efficient, if it is binary or linear. So I am using count equal 0. So here I will increase the count by every loop. Count plus plus. After that I will use one more printing statement. The target is found in iteration. Here I will give it as count. So let us check for the same value to the binary. So let us check here. So again 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. And I give the target as 6. So the element 6 is in the array index of 5 and the target element is found in the 5th iteration. So after note this, we have found it in the 5th iteration. We will give the same input for the binary values and check in the which index we have get the value. So now this is the linear search. So now we will be moving on to the binary search. So it will still be there. We will just remove this one because the index is -1 again, and we just need to change the method of it. So for the while loop, we can use, in the binary search we will be using while loop, and we are going to use 2 pointers there. For that is, first we have to find the middle element. So for that I am using 3 things there, that is left, right and middle. So I initialize it, that is int left value is 0, the right value is n-1, that is the last element, and after that we will be getting into the while loop, that is while we already know the condition for it, that while we are using 2 pointers, that is left less than or equals right. So we are using less than or equals here because we already know that it can be in the middle element. So in the middle element it can be the same value, so that's why we are using less than or equals. While reversing we don't need to check that, we just need to reverse it, but for searching we have to check. So that's why we are using less than or equals. It may be in the middle element, so that's why we are using less than or equals. So for middle element, mid is, I can say that left plus right divided by 2. So this 0 plus 0, 1, 2, 3, 4, 5, 6. So 0 plus 6 divided by 2, that is 3. 0, 1, 2, 3. We got the middle element. So left plus right divided by 2 is the formula to find the middle value. So I am checking if, first we have to check that if my middle element is the target element. Middle element is my target element. If it is, I'll just index is my mid. So after that, after finding it, I can break. So if not, I have to check if my current value is less than the key value or not. So else here, my array of mid is, so here we have to check the array of mid. We are checking with the index value instead of the target. So that is S or C. If my current element, that is the middle element, is less than the target value, so that time I can say that my left value is middle plus 1. So if my, see here, if my middle value that is less than the target, okay, that time I have to search the right element. So that I can move this pointer of left to this middle plus 1. So that time my left will be here, my right will be here. Okay. So after that, if not, I have to move to the right side, that is mid minus 1. So if it is greater, if the middle element is greater than the value, we have to move to left side. If it is less than the value, we have to move to the right side. We are moving left side for the middle element is, the target element is greater than the middle element, and we are going to the left side if my value is less than the value. So we are checking here, we are checking with the middle element only. If my middle element is the target, will be break, or else we will be checking. So every time I have to increase the count by 1. So let us check by running it. So we are giving the same input 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the value is 6. So the index is 5, but we got the element in the second iteration. There is 2 iterations. Within only 2 iterations, we have found the value. But there we have found in the 5 iterations. So let us check one more time. So 5, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 9 and 6. So I have only given the value, so we have to give 10 here, the size. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 9. So the target is 6. So see here, in here the target is found at the second iteration. Okay, that means we only use 2 loops. So let us see the structure of it. So this is the array structure, and here it is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 9, the target is 6. So the size, that means the left value is 0, the right value is 9. So we have to find the middle element. So middle is 0 plus 9 by 2, that is 9 by 2 will get 4. So 0, 1, 2, 3, 4. That means this is the value here. Okay, 0, 1, 2, 3, 4. So in this value, we have to check that which element is we have found it or not. So here, if you, as you can see here, this value is currently 5. So the 5 is, the target is 6. So we can see, first we have to check 5 equals 6. No, it's not. Then if my 5 is, the middle element is less than the target, so that time my left value will become 6. So these values will be removed. So this is my current array now. So the left value is, currently it is 0 and 0, 1, 2, 3, 4. So 4 by 2 is 2. So as you can see that 2 will be there, 0, 1, 2. So the index is 2, that means the value of 8. So 6 is less than 8. So that time these values will be removed. So now if you see here, there are two values. So 0 and 1. Okay, 0 and 1. So 0 plus 1 is 1. So 1 by 2 will return 0. That is first index. So we got 6 equals 6. So that time will be written. There are 3 times this loop is running, but because we have given the last there, it is counting only 2 times. We have to give it here. So now if you check it and give the same value of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 9, the target of the 6. So it is found in the third iteration. For the linear search, it will be found at 1, 2, 3, 4, 5 and 6. It will be found in the sixth iteration and it is found at the third iteration. But there is one more limitations is there for the binary search, that the array have to be sorted. If it is not in a sorted way, it will not work perfectly. But for linear search, there is no need for sorting. So the sorting range is O of log n. The time complexity is very less compared to the linear search for the binary search. So that time we will be using binary search, and this binary search is much faster than the linear search. So what we are doing? We are doing that two type of searching. The two types, one is linear and one is binary. Binary is nothing but we already know that is 0 and 1. We are checking left or right and we are moving based on the splitting each array. Let us take an example that there is a 10,000 of size of array. For the first time, the binary search will reach to 5,000. After that, 2,500. After that, 1250. And after that, it will reduce it based upon it. So it will be continuously reducing. But for linear search, it starts from 1 to 10,000. But for binary, it will be reduced each and every time by half. That's why we will be using binary search for a larger size array. Comparatively, binary search is much more faster than the linear search. There are other more. So we will be seeing one more sorting algorithm, that is bubble sort. We are going to sort the array. For example, if there is any array like 1, 3, 2, 4, 9, 8, 7, 5, 3, 7, 2 like this. After the sorting, it will be like 1, 2 and 2, 3 and 3, 4, after that 1 5 there, and 7 and 7, 8 and 9. So this is the sorting of the array. So this is the normal array and this is the sorting of the array. So we are going to do bubble sort. So a bubble sort is nothing but we will be sorting through every elements by checking it from the each pass. So it will swap based on the larger bubbles to the end pass. So let us see that how it's working. So first let me write the code. So I'll remove this code. So this is the target array, that is we are going to getting the element. So I'll remove this. So we are getting the size. After that we are getting the array elements. So this is the basic structure. So I am naming it as array and I am giving the size of n and array. So this is the basic array. So after that we have to sort it. So I'll like to use method function. So for that I'll create one more method. So I don't want any return type. So I'm using void. So I'm naming it as bubble sort. With this we have to give the size of the array and the size of the array. So after that, first I want I, j and a temporary variable to swap it. So after that, first we'll be using one loop to iterate through the first element. So I value is 0 and I is less than n minus 1 and I plus plus. So here we are checking till n minus 1 because we will be checking the current value plus I plus 1. So for we will be checking from the 0th index again, and here j less than n minus 1, n minus 1 minus I. So each and every index we have to skip the last element. So first in this bubble sort we will be check the current element is the array of j is greater than j plus 1. So if it is greater element we will be swap it. We will be swap and get back to its larger position. For example, let me take some example like 54 and 34, 25 and 12 and 22 and 11 and 90. So here this is the array. So first I'll check that if my array of this element is greater than the next element. Okay, if this element is greater than the next element, I will swap it. So for the next swapping, it will become 34, 64, 25, 12, 22, 11 and 90. Like this it will be still there. So now it will check 64 is greater than 25. So it is. So after that it will again change. Now what will happen? 34 is still there. 25, 64, 12, 22, 11 and 90. So after that 34 will be there, 25 will be there. We will check 64 is greater than 12. So it is. So 12 and 64. We are swapping these two values. 22 will be remain same and these two will be remain same. Now 34, 25, 12. Now we will be check 64 is greater than 22. Yes, it is. So 22, 64, 11 and 90. So 34, 25 12 and 22. Now we will check 64 is greater than 11. So now we will check and swap it again. So 64 and 90. So now this time we will check this. 62 is greater than 90. So it will remains the same. 34, 25, 12, 22, 11. So 62 is less than 90. So it will not swap. So now for the first full iteration, as you can see, the largest element will be get into the last. So that time we don't need to check the last element anymore. That's why we are giving minus I here. So it will not check the last element. So for this n minus 1, why we are giving is because we have to check j plus 1. So that time it will get out of the range of the loop. So we are giving n minus 1 here and we are giving minus I here. So after that j plus plus. So we'll check if my current element, this j is greater than the next element. So that time I will swap it. So array of j is array of j plus 1 and array of j plus 1 is temporary. So now we are swapping it. So that's it. This loop is for the first iterating through the each and every loop, and after that this loop is for iterating through this many elements. Let me open this. As you can see here, this is the first iteration of this loop. Okay, we are iterating first time for this loop. So now let us move on to the next one. So after swapping this, we can see the next one. So first I'll try to print this. So as we can see the every iteration of this loop, for the every iteration I have to print the loop, print the every values for I is 0, I less than n and I plus plus. So we can't give I here because we already used I here, so I'll use k. So now we'll print the array elements to check the every iteration. So I will give the unsorted array elements. Let me open it. That is 34, 64, 25, 12, this value. So first let me give the size of the array. That would be 3, 7. That is 7. So after that 64, 34, 25, 12, 22, 11 and 19. So we didn't get any element because we didn't call it. So first, so we'll printing here. So we just need to call it here. So for calling, we just need to call the name bubble sort, and within this we have to give the array and n. That is the size of the array. So now let us run it. So the size is 7 and we will give the value, that is 64, 34, 25, 12, 22, 11 and 19. So this is printing through every iteration. After every iteration I want to give a space, that is next line. So println next line. I will copy it and create new project. So now let us run it. And I'm giving 7. Now 64, 34, 25, 12, 22, 11 and 90. So see here, this is the iteration of the every loop. In the first loop, as you can see, 90 is in the last, and the second loop, the 64 is there, and 34 is there, and 25 and 22, after that 12, after that 11. Each loop, the largest value in the array would be get into the last value. So let me give in a reverse order for the another input. Let me give 7. So in this I'll give in the reverse order. So 90, 65, 45, 78, 54, 32, 12, 65, like that. There are already 3, 6, 7. So as you can see here, this is the iteration of the loops. So first 90s come to the last. After that 78 is the come to the last. After that 65 come to the last, and 54 come to the last, and 45 come to the last. So after that 32, after that 12. So in this array we got every largest element get into every single this loop. If you run this loop one time, you will get sorted the largest one element to the last element in the array. Likewise, we are running to every element but n minus 1 times, because if you do see here, as you can see, when it arrange this 32 here, this element is already sorted. So there is no need for checking one more time. That's why we are given n minus 1 here. And n minus 1 minus I is because we don't need to check this last element, we have already checked there. So that's why for that. So let us move on to the next question. So this is the basic sorting method that most of the people will know. The next problem is, we will be counting the occurrences of an element. That means we will get a target element and check how many times the element is there. So I will remove this. And this is bubble sorting. There are a lot of sorting is there. Insertion sort is there. Merge sort is there. Quick sort. Heap sort. So we will be seeing on the later that, because we will be having one more DSA live course is there. So that time we will be seeing every DSA course, sorting and searching methods. After that we will be having dynamic programming also. So now we will be seeing another problem, that is counting the occurrences of an element. So for that I will get the target element. I want to count target. After that I will print, enter the element. So I need target. So enter the target element. So after that I'll use scanf. So after I am getting the target element, I want to count it. So for counting it, I am using one variable. So count equals 0. For int I is 0, I start from the first element and end through the last element. I less than n, I plus plus. So here, if my current element is equals to my target element, so that time I can increase the count by 1. So count plus plus. So after that I'll print percentage D, the number is occurred this time. So here first one is the number that is we are getting from the user, that is target. After that the count. So the size, that is 7, and 1, 2, 3, 2, 1, and 1 and 4. So my target is 1. So 1 is occurred 3 times. 1, 2 and 3. We are iterating through the array. After that we are checking if the current element is the target element. If it is the same element, that time what we are doing, we are counting it by 1. After that we are printing the total occurrences of the target element. So now let us move on to the next problem, that is we are going to remove duplicates from the sorted array. So let us take example. For example, let me take one array like 1, 1, 2, 2, 3, 3, 4 and 5, 5 like that. So this is the array. In this array, what I want is, I want to remove the same elements that occurs more than once. After that, I want to return the size and the elements in the array. So this is what we are going to do. So now let us move on to that. So I will remove this code. So now I would like to create one more method. So in this method, I'll name it as, in this I'll return the size int remove duplicates. So in this I'll give array, integer array is the input and the size. So in this method, first here my array size is 0, that time I'll return 0, because if array size is 0, there is no element within the array. So after that we will be checking the elements in the present array. So for that, what we are going to do is, here first let me take two variables I and j. So these variables, first for my value of I is 0, so I already declared. So I is, I would like to go on from the first element and I'll check from the before element by that. So I is 1, after that I less than n and I plus plus. So in this, if my current element, that is array of 1, is not equals array of j. So see here I am using two pointers, j for previous element, I for the next element. So this is I, not 1. So my array of I is not equals array of j, that time I can move on to the next element. After that my array of j, that is my first element is array of I. Okay, see here, this is the value that is currently stored. Initially it will be 0, so after that it will be incremented to the next element. So that is one. If my element is different element, that time I don't need to check, because I already said this array is in a sorted way. So 1, 2, 2. So in this array, first this pointer will have j and this pointer will have I. So now what I am checking, if array of I is this element is not equals array of j. So that time I'll move this pointer by 1. So after that I will be pointed here. Now it will check array of I is not, that is my current element array of I2 is not equals array of j. So that time this condition will be false. So that time it will not be added. So the I will be incremented here. So now it will check if my current element is my array of I is not equals array of j. So it will become true. So that time this value will be there, and this will skip this current 2 and move on to the next value. Likewise j will come here. So I will come to this 3 and it will check. If it is false, I will skip this value and move on to the next value. So now after that 3 will be stored, and this value will, this current 3 will be skipped. After that it will come to here. So this is what we are going to do. So next we have changed the value, that is array of j equals array of I. So finally it will skip all the value and we have to return the size. So return the j is the index value. So the size would be index plus 1, because n minus 1 is the last value. So n plus 1 is the size. So j plus 1 is the current size. So after you calling this method will be changing the values inside it. So let us call it. So int size equals this value. After that for I is 0, I less than size, I plus plus, and we are printing this array. So let us run it. I give size of 8, 1, 1, 2, 2, 3, 3, 4 and 5. So see here we got removed all of the duplicates, but we didn't print the size. So for that I'll just print it within the function printf size of this array with unique elements is percentage %d. The size will be j plus 1 because j is the index value. So now let us run it. So the array size is 7 and 1, 1, 2. So this 3 is nothing but the size. So after printing it, we have to give next line here. So let me give size of 7. After it, so see here, now the array is being sorted and it only returns the value of the unique element. So now we have written the code for removing duplicates in a sorted array. So now let us move on to the next problem. That is, we are going to find that is the second largest element that is present in the array. So for that, I will remove this entire code. We can remove this code as well. So have include standard input output dot h. After main function and return 0. So now we have to find the second largest element in the array. For that, first let me give the size of the array. So there's no need for this printing statement. We'll just scanf. After that, we'll get the elements from the user. So for that, for loop, and we have to scan it to the index of it. So before that, we have to declare an array. So int array with the size of n. So scanf %d to the current array element, array index. So after storing the element, we have to check the second largest element. So for that, first I'll get two values, that int first. So I'm declaring initializing with the value of 0. So int second largest, I'm again initializing it with the first value. So then for I'll start from the first index, I is 0. After that, I less than n and I plus plus. We are iterating through the array, and if my current element array of I is greater than the first element, so that time we can say that it will become the second value, because now this current array of I is first and this first will become second. So second will become array of, it will become first, not array of I. So first, so the first will become the array of I. If you do these things reversely, first we have to calculate this value, after that we have to change this. If you do first before the second value, so that time both value will be same, because the first value will be always, the first value will be already changed to this value, after that this value will be remains in the same value. Okay, so for that first we have to calculate the second value, after that we have to calculate the new first value. And one more condition is there, else if that means the array of the current element is greater than my second largest element and my array of I is that means the array of I, the current element is less than the first element, first largest element, and greater than the second largest element, so it is the second largest element. So second is array of I. So these are the two conditions. That is, if it is greater than the two values, let me take one example. First value is 21 and second largest is 12. So if I get my array value was 34, so that time the first largest will be 34 and it has to be the 23 or 22 something. So this value. So if you do first change this and store it here, it will still change to 34 as well. So that's why if it is any value like 21, first we have to change this 21, after we have to change this to 34. So that time it will work perfectly. So this is how condition is for if my array of I is like 25, it is the second largest because it is greater than 21 and less than 34. So that's why we are checking else if condition here to change this value to this value. So that's why we have given two conditions. If my element is greater than two values, we will swap it. If it is only greater than the second value, we will swap the second value only. So now we can print it, that printf the second largest element in the array is %d. After that, I will give the value that is second. So now we can print it. So the size is 7 and I give 7, 8, 6, 5, 9 and 3 and 10 here. So now the second largest element is 9. So let us check. The second largest element is 9. So it is correctly printing the second largest element. So let me check the first largest. So before that, I'm using /n to go to the next line. So now let us run it. So 7, 1, 4, 5, 6, 7, 8, 9. So in here, 8 is the second largest element because the largest element is 9 and the second largest element in the array is 8. So let us move on to the next problems. That is something based on some is like a real world scenario problems. Those are, first one we will see leaders in array. So first we will see that what is the leaders in the array. First we will see what it has to be a leader. Let's see one more example for that. For example, there is an array with 16, 17, 4, 3, 5 and 2. So if a element is greater than the right side of its all of it element, it is a leader. If 17, let us take 17, it is greater than all of the elements in the array. 17 is greater than 4, greater than 3, 5 and 2. So 17 is a leader, but 16 is not because 17 is greater than 16, so it is not a leader. So if you see 5 is a leader because 2 is only the right side one, and 2 is also a leader because there is no elements besides it. So So 2 is also a leader. So we have to check how many leaders and we have to print the leaders. So now standard input output dot h, I'll write the main function and return 0. So first I'll get, instead of it I'll directly declare the array. So int array, so 16, 17, after that some more values 4, 3, 5 and 2. So this is an array. So after that the size would be 6. So in n is 6. So if you want to find the size of the array, you have to use size of. But if I give size of array, I'll get multiplication of this size of array by 4 because it will store it as 4 bytes. So let us try to print it. So printf, so if I print it, it should return 24 because 6 elements and each is 4 bytes. So 6 times of 4 is 24. So most of the systems will differ based upon the number of bytes it can consume. So for that you have to divide it with size of the array of first element. If you do that, you will get the size. Now I got the output as 6, that is the number of elements that is present in this array. So let me remove this. So after that I'll use one boolean value, is leader or not. Or else we can use one integer value, int max is 0. So see here, I can say the rightmost element is a leader anyway because there will be no element besides it. So first I'll create one more array and store 2 in here as the first element. After that I'll check if my current maximum element, first my maximum element is 2. So now I can check if this 2 is any element that is greater than this 2 or not. If my current element is greater than this maximum value, so that is also a leader. So after that I'll add 5 here and 3 is not greater than 5, so it is not, and 4 is also not greater than 5 and 17 is greater than 5, so 17 is greater than 5 and 16 is not greater than 5. So this is what I am going to do. So I'll initialize this value with n minus 1, the last value. So I'll create one more array, int result with the size of n is, so my first element is the last element. Okay, so for indexing I'm using one more variable. This is 0th index value. So for the first index I'm using idx as 1. So we'll iterate through the reverse value for I value is n minus 2. N minus 1 is last element, that is 2. So I'm checking from this value because we already know this is a leader, so we have to check from it. So after that I greater than or equal 0, and I minus minus. So here my array of I is, my current element is greater than my maximum element. So that time I can say it is a leader. So I'll store it in the array, that is result of index plus plus array of I. My current element will be stored as the leader in the array. So this plus plus will move the index by 1 after adding it, because I am using post incrementation here. So after adding it, this will be moved on to the next pointer, that is I will be incremented to 2. So if it is not, it will not do anything. So now it will check and add the element to it. So after checking it, will be printed. So for int I value is index minus 1, because after adding it, it will move on to the next element. So index minus 1 and I is greater than or equal to 0 and I minus minus. So we are printing it from reverse because it is stored in a reverse order 2, 5, 17, but we want to print it in 17, 5, 2. So we will be printing from the reverse. So printf %d space result. So using a single for loop, I have iterated through reverse and store it. After that I am printing in another loop. So let us check it. So here it is printing 16, 17, 2 values. So let us check here. If array of I is greater than the maximum value, that time it is changing, but we didn't change the maximum value. So max value will be array of I. So now if I run it, so now we are getting the leaders in the array. So the leaders are 17, 5 and 2. So in this array, see here the output is 17, 5 and 2. 17, 5 and 2. It is stored in the reverse order, but the leaders are 17, 5 and 2 here. So let us move on to the next question. So in this question, we will be given an array. In this array, there will be values with zeros. For example, 0, 1 and 0, 3, 12, 0 and 5. Like this, there will be an order. What we have to do, we will not change the order of the normal numbers 1, 3, 12 and 5 and remove the zeros to the last. So this is what we are going to do in the next problem. So for that, we'll go on to the problem that first we'll delete this. So in this main function, I'll create one array. In this array, I'll give some random values 0, 1, 0, 3, 12, 0 and 5. So this is an array. So the size is 7. So after that, I'll use two variables. The first one is for finding the index. So I am using position is 0. So after that, I'll use for loop I is 0. So I less than n and I plus plus. I am iterating through the loop. So in this loop, here my current element is not equals to the 0, so that time I can arrange it to the first position, that is the index array of position plus plus equals to the array of 5. So now what will happen? So first it will check 0. So 0 is not equal to 0, false, so nothing will happen. So it will check 1. So there will be an indexing value that is pointing to it. So the index will be initialized with 0. So now the first index will be 1. After that the second will index, that is 0th index is 1 and the first index is 3 and the second index is 12 and 5 will be there. Now we have to fill all other zeros, all other values with zeros. So now we have changed the values, but we have to add zeros to it. So for adding it, we'll get out of this for loop, and while we have already get into the current position, so my index is less than n, that time I will add array of position plus plus will be 0. So now I am filling these empty spaces with 0. So now we will print the array. So for I is 0, I less than n and I plus plus. So now we will just need to print it. So here if it is not 0, I am aligning it with the index value of using another variable. After the remaining values, I am filling this value of the array with the 0. So let us run it. So we got the value, but there is zeros there. Let us remove this and give space. So see here, all the zeros were pushed back to the last element. The order of the numbers will not change. It will be 1, 3, 12 and 5, but the zeros only pushed to the end of the code. So let us move on to the next question, that is find the missing number. So if array, for example, an array would be like this 1, 2, 4, 5, 6. As you can see, the missing number is 3. So let us move on to the next one, 1, 2, 3, 5 and 6. In this, as you can see, the missing number is 4 and 1, 3, 4, 5, 6, the missing number is 2. So we can use n plus sum of n numbers, and if we subtract it, then we will get the value. For example, if you add all of this, so 4 plus 6 is 10, 10 plus 5 is 15, 15 plus 3 is 18. So 18 will be subtracted from the value of 1 plus 2 plus 3 plus 4 plus 5 plus 6. So here 18 plus 3 will be 21. So 21 minus 8 is 18 is 3. So now we can see that 3 is the missing number. So we have to add n numbers, the sum of n numbers minus the current number that is present will be give the value of the missing number. So this is, I'll remove this code. So here let me give an array. Within this, I'll give value 3, 5, 1, 6. So we know that 4 is the missing number. So first I'll put the size. The current size is 6. So now we have to add the expected sum. The expected sum is, the formula for finding the sum of n number is n multiplied by n plus 1 divided by 2. So this is the expected sum. So here we have to find the actual sum. So in actual is initialized with 0. So I am using a for loop and adding it every element in the array. So after adding it, so why I given 6 but there are 5 elements? Because there would be some missing element inside it. So if I use size of, so that time I have to add this total value by 1. Because if the number is missing, it should be increased by 1, right? So that time the n would be increased by 1. So now printf the missing number in the array is that would be expected value minus the actual value. So now let us check. It should return 4. So it is returning some more value, n multiplied by n plus 1. So here I'll just simply give 6 for the size. The expected is n multiplied by n plus 1, and after that just run it. It says some other value. So here we have to give n minus 1 because it is adding one more garbage value, so that's why it is added some more value. So now we got 4 here. So let us remove this 3 and give 4 and search it. So now the missing number is 3. So now I give 3 and 4 and 5 and remove 6. So it should return 6. So it is returning the number 6. So for finding the missing number, we will be adding the sum of n numbers. After adding the sum of n numbers, we are subtracting the actual value with the expected value. So after that we will get this original value. So now let us move on to the next problem. That is, we are going to check if a current array is palindrome or not. So when I can say if array is palindrome, that means, for example, an array should be like this: 4, 5 and 6. If my array is being reversed, I'll get like this: 6, 5, 4, 3, 2, 1. If both of them are still same, that is a palindrome. For example, I'll give 1, 2, 3, 4, 3, 2, 1, and if I reverse this array, I'll still get 1, 2, 3, 4, 3, 2, 1. So this is called a palindrome. As you can see, we can check this first and last is same, and the next value and this value is same, and this value is same. So if in between any one of them is not same, I can say it is not a palindrome, or else it is a palindrome. So for that, I'll remove this. Let me create one array. Int array is 1, 2, 3, 4, 3, 2, 1. This is the palindrome array. So the size is 5. After that, left value starts from 0 and the right value starts from the last value, that is n minus 1. So I am using one more boolean, that if it is fails or not. So for that, initially I will given it as false and initialize with true. So if anything happens, that means if any value changes, I'll make it as false and return it. So while left value less than right value, so we'll be giving the pointers from left to right. So here my array of left value is not equals to the array of right. So then I can say it is not a palindrome. So I'm giving it as 0. 0 means false. So I have to increase the left one and reduce the right one. So right minus minus and left plus plus. So after that, I'll use ternary operator here. Printf within it is okay, palindrome. If it is not a palindrome. So if it is true, palindrome will print. If it is false, not palindrome will be printed. So let us check. It says the current array is not palindrome. I'll use break here. So we are initializing it with 1. So let us check once again. So if it is true, palindrome will print, or else not palindrome will print. So I have given the size is wrong. It is 7. 367. So now let us check. So it is palindrome because there are 7 elements here. So let us give some random values. If I remove this, it should return not a palindrome. So now if I give the same value, so now check, it is a palindrome. So it is a palindrome. As you can see here, this array is having the element starting and reversing as the same value. So if you reverse this array, then also you will get the same array. So that's why we are getting the values true. So this is a palindrome. So we will be moving on to the next problem. That is, we are going to count negative numbers in the array. I am using size of here. So within this array, we will be using a for loop for and go to the last element, and if my element is all the negative values are less than 0. So if my element is less than 0, so that time I can increase the count. So for that I'll create one counter with 0 and I increase it. So I'll increase the count by 1. So after that I'll do one more thing, that is I'll be adding the sum of it. So I'll declare one variable, sum is 0 and sum plus equals array of I, the sum of negative elements and the count of it number. So here I would like to give some more values, 3 minus 1, after that 5 minus 4, 6 minus 8, 0, like this. So in this array I want to add all of the negative elements. So after adding, I want to print the total count is count. After that, the total sum is the sum I have added. So let us run it. So the negative elements are 3 elements, 1, 4 and 8. If you add it, we will get negative 13. So this is count and sum of negative numbers. So now let us move on to some more problems. So in this problem, we are going to rearrange the positions of negative numbers and positive numbers. For example, I'll give an array like negative 2 and negative 7 and 9 and 8 and negative 5 and 9 and negative again negative 5. In this, I want the output as minus 2, minus 7, minus 7, minus 5, 9, minus 5. So here it will not like this, minus 5, minus 5, 9, 9 and 9. See here I arrange this negative value first, after that I arrange positive value to the next. So this problem we are going to do that. So in this what we are going to do, when a negative element found, we will be shifted to the right element of it. So let us see that. So let me remove this code. This is the array and the size. So here I have an array. So after that I have the size. So in this, first I'll use a for loop for int I value is 0 and I less than n and I plus plus. I will iterate through this array. After that, if my array element is, that is my current element is less than 0, so that time I'll use one temporary variable, and after that array of I am storing it in a temporary variable. Now I will use one more for loop for int j value is initialized with the current value I. After that, j greater than 0 and array of j minus 1, that is the previous element. If my array of j minus 1 is greater than 0, that is positive element, then j minus minus. Okay, in this condition, my array of j equals array of j minus 1. I am swapping the positive element with the negative element. I am checking j is greater than 0, that means it will not go to the negative index, and that time I will get j minus 1, the previous element, and j minus minus. That time I am reducing from the current element and checking and swapping it through this value. After that, my array of j will store the temporary value. So first I will declare this j out of the loop. So I will remove this. So now this array of j will be stored with the temporary variable. So now this value will be interchanged when positive and negative. First all the negative value will be printed and the positive value will be stored. So now let us try to print it. See here, we have aligned all of the negative value before and all of the positive value after that. So what we are doing, we are checking if my current value of j is negative value. If it is negative value, then I will store it in the temporary variable. After storing it, I will check positive value. After that, I will swap it. While doing it, all of the negative value come to the next side, left side, and all of the positive value will come to the right side. So let us see one more problem, that is finding the duplicate elements in the array. So let us remove this. So now I will give one more array. Within this array, I will give some random values like 1, 3, 4, 2, 3, 5 like that. So in this array, I will give after that size. This is the array. After that, in the end, I am storing the size of it. After it, I want to declare two variables, that is int I and j for the double for loops. After that, I am using one boolean for finding the first duplicate. So now I have declared 3 variables. After that, printf I is 0, I less than n, I plus plus. So now for loop, I'll start through this. After that, initialize with the value of boolean 0 because 0 is false. I'm checking if I found it or not. So after that, for j value will be 0 and j less than I and j plus plus. So I am checking 0th index to the current index value, and if both of them value are same, so that means this value will be have a duplicate. If array of j is equals to array of I, so that time I'll do found equals 1 and I'll break it. So I'm checking these both values are same. If both of the values are same, I'll make it as found equals 1 and I'm making it. After that, after this for loop, if it is found and array of I is, I'm giving not equals minus 1 because we are checking for duplicates in that. If you give minus 1, it will not check for negative, it will only check for the positive values. So after that, printf %d and array of I. So after printing it, I want to check if it is not or there. So after finding it, we have printed it. So now we will make it as mark of minus 1. So we have already printed. So this is nothing but marking it to be printed. In array 1, 3, 4, 5, 2, 2, 4, 5, 6 like this. It will come and check 1 is there. So 1 is not there. So after that 1 will be printed and in here it will be marked to minus 1. Same like that it will print and it will make it as marked as minus 1. And check if my current value is, that's why we are checking the current value is not equals to minus 1. So let us print it. So we are printing 2, 3, after that 1 here in this array. So it is checking the array and printing duplicates values only. So 2 is a duplicate value, 3 is a duplicate value and 1 is a duplicate value. So here it only print duplicate values and it will not print unique values. If there are any duplicate values there, it will mark here and it will become minus 1. If it against minus 1, so it will not print and it will skip the value. So that time we are writing a program to print only unique values that is not present in the current array. So now let us move on to the next question. So in this question, so the next question is we are going to print all the unique elements present in this array. So for that, we are going to use this same method but in a different context of that. Just remove it. For that we are going to count it. So for int I0 and I less than n and I plus plus. So it is iterate through the loop. So I want to create one more array to count the frequency of it. So I am giving 100 here and I initialize with 0. So in this array, if or else we can simply say frequency of array of I plus plus. Frequency of array of I plus plus. So now this value is this value will mark these values in within this array. If there are zeros like that, it will mark it. After that, it will start from 0 to 99 here because this is 100. So if I want up till 100, I have to give 101. So now I will check the frequency of it and count it. So after that, I will get through this loop. So this is 0 to 101. So in this loop, I will check if frequency of I is exactly 1, that is unique element. Okay, I am counting the frequency. Frequency is nothing but how many times, if let's take this as an example, the frequency of 1 in the array is 3 and the frequency of 2 is 2 and 3 is 1, 4 is 1, 5 is 1, 6 is 1. So these 4 elements are unique element. So let us give it as an example here. So let me give one here. So let us run it. So here we have given one more thing, that is we have to give a frequency of I. So now run it. So we have given wrong. We have given to array of I. So now we are printing the unique elements. Here it is printing 1 to 4. So I 0 to 1. So within it we have to give frequency of I. So this is containing the value. So just need to print I because I is the index value, that is the original value of it. So the values are 3, 4, 5, 6. So in here these are having only unique values. So if I give another 3 here, so now if I run it, 4, 5, 6 are unique element, 3 having one duplicate value. So this will count the frequency. If my frequency is exactly 1, that time I'll directly print it. So that's all for the today's live. So thank you for watching. So in the next live we'll be covering strings and after that we'll be covering functions as well. So these questions will be shared on this comment within 1 hour. So make sure to get through it and solve those problems. So thank you.